Hello students, in this video we'll discuss the interval of convergence of a power series. If we're given a power series, the sum, n goes from 0 to infinity, of Cn x minus x0 to the n, we can use the ratio test, the ratio or root test to find the values of x for which the series converges. Absolutely. Okay. So let's see a couple examples how we would do this. Let's consider this series. The sum, n goes from 0 to infinity, of n over n plus 1, 4 to the power n, x to the power n. And we can note that these terms over here are positive, so what we have is we have a series of positive terms. And so we can apply the ratio test. So by the ratio test, we want the limit as n goes to infinity of, let's call these terms over here, these are like our a sub n, of a sub n plus 1 x to the n plus 1 over a n x to the n in absolute value to be less than 1 for the series to converge absolutely. This is the n plus first term, this is the nth term, and that's the ratio test. And so we can fill in these things, and so what we're going to have is we'd like the limit as n approaches infinity of, so an plus 1 will be n plus 1 over n plus 2, and then 4 to the n plus 1, x to the n plus 1, over n to the n plus 1, 4 to the n, x to the n, in absolute value to be less than 1. Now lots of things will cancel over here, so this 4 to the n will cancel with this 4 to the n. This x to the n will cancel with this x to the n, so there'll be 1 power of x left. And so what we have over here is we have that the limit as n goes to infinity of, I'll put the 4x over here, I'll pull that 4x out, and then we'll have this ratio over here, this is going to be an n plus 1 squared over n times n plus 2, and I want this to be less than 1. Well, this 4x in absolute value can come outside, and then we have the limit as n goes to infinity of n plus 1 quantity squared over n times n plus 2. I want this to be less than 1. Now this limit over here has a leading term of n squared over here and n squared in the denominator, so this limit will tend to 1. And so we need that 4x in absolute value is less than 1, so that tells us that the absolute value of x needs to be less than 1/4. So if the absolute value of x is less than 1/4, then we can see that this series will converge. Now, the other thing we need to do with these series, we need to figure out the endpoints included. So we do the endpoint tests. So that we test the endpoints. So we plug in, if we plug in x equals 1/4, that's the endpoint of this interval, because this interval can be written as negative 1/4 to 1/4. So if we plug in x equals 1/4, what we'll get is we'll get the sum, n goes from 0 to infinity, of n over n plus 1, and then 4 to the n, and then 1/4 to the n. And that 4 to the n and 1/4 to the n will cancel out. And we're left with the sum of n over n plus 1. And this series will diverge by the divergence test as n over n plus 1 converges to 1, and that's not equal to 0. So that converges by the divergence test. And then if we plug in the other endpoint here is negative 1/4. So if we test x equals negative 1/4, what series will we have? Well, we will have the sum, n goes from 0 to infinity, of n over n plus 1, and I'll have a 4 to the n, and then a negative 1/4 to the n. And so we have an alternating series. We have the sum, n goes from 0 to infinity, negative 1 to the n over n plus 1. Now this is an alternating series, but again, since these terms over here, this n over n plus 1 converges to 1 as n goes to infinity, we see that this diverges. So neither endpoint work, so our interval of convergence is negative 1/4 to positive 1/4. And this is an example where neither endpoints are in the interval of convergence, but we can see that there are also examples where one endpoint is included or both endpoints are included. Thank you very much.